In the last video, we tried the formula for finding the displacement of the shadow or the projection of a particle, which will gonna execute the simple harmonic motion, but of course not the particle. The particle will gonna execute the uniform circular motion. Its shadow, its projection would gonna execute simple harmonic motion. So we found or we derived a formula for finding the displacement of the projection of a particle, right? And that formula was x is equal to either r cos theta or x is equal to r cos omega theta, r cos theta or r cos omega theta, right? In today's video we'll not gonna drive of course, but we're gonna find the maximum displacement and minimum displacement, since these both cases are very must. Here maximum, here minimum. The maximum displacement. The maximum displacement. And here we will gonna find the minimum displacement, and we'll gonna find their positions too. Now see, this all depends upon this theta degree, right? If I do make the 0 degree of this theta, if I do make the 0 degree of this theta, which means now this line would be like this, or now this line would come here. See, we had theta here, but now I'm making 0 degree, which means now I'll have theta here, right? That's why this would be maximum displacement, right? So I must write at 0 degree again. Listen, why have I taken 0 degree? Since if I'll take here the 0 degree, this line would go straight, because cos 0 is equal to 1, right? So this line would go straight, and we have already learned that displacement is always taken away from the mean position, which means this entire is the displacement. So this is a true condition, right? Here we're gonna have maximum displacement when we'll have 0 degree theta, right? 0 degree theta. Now see, we have already learned the formula. X is equal to r cos theta, right? Theta is equal to 0, this we have already taken. So x is equal to r cos 0 degree, and this we have already learned that cos 0 degree is equal to 1. Cos 0 degree is equal to 1. So let's put this in the formula. R, instead of cos 0 degree I can put 1. So x is equal to r. Now see, x would be equal to r if we have the maximum displacement, right? Now see, this is entire r. This we have already know, right? This is the entire r, right? So x is equal to r. The maximum displacement would be that when our displacement would be as it is, would be equal to the radius of the circle. Our displacement of the shadow or the projection of a particle would be same or as it is or equal to the radius of the circle. Radius of the circle on what the particle executes the uniform circular motion, right? So this was the maximum case. Now see, maximum case would be where? At the mean position or at extreme position? This we have already learned. At mean position, our displacement would of course be 0, right? But displacement is always taken away from the mean position, which means our displacement would be maximum here. And this position is extreme position, this we already know, right? So our displacement would be maximum at extreme position. At extreme position. Let's learn second condition, which is the minimum displacement. Now see what degree must I make, so that here I must have minimum displacement. Now see, if I make a circle here, initially our uh, you know what, particle was here, and this uh, was making some theta or some degree with it, right? But now I want to make my displacement minimum, right? Now I want to make my displacement minimum. If I do draw a projection here, here I'll have some x, right? But now I need to make my displacement minimum. So if what I take my this line here, this straight, and this theta I make equal to 90 degree. 90 degree. Now see, particle is here, particle is here, and now see the displacement of it. This is straight, which means on the center point, which means zero displacement, right? Which means my theta is equal to 90. For minimum position or for the minimum displacement, I need to take my angle as 90. Since if I'll take my angle as 90, so this line would go straight, and this would make some theta with it, and that theta would be equal to 90 degree, which means right angle triangle, right? Now again same formula, x is equal to r cos theta, right? And we have theta already given, so x is equal to r cos 90 degree. Since we have taken 90 degree, theta is equal to 90 degree, and we know that cos 90 degree is equal to 0, right? So let's substitute the values. R, instead of cos 90 I am putting 0, so x is equal to, r zeros are of course 0. So this is, as you can see, x is equal to 0 means our minimum displacement. Now see where this would be, where this would be lying, right? Now you can see this position is what we call the mean position, and these both position we called them extreme positions. So here we will have our minimum position, right? Here we had our maximum position, which means extreme point, we had our maximum position. But here we will have our, right, minimum displacement, which means this is a mean position. So at mean position, minimum displacement. In all cases, in all of the three cases we're gonna discuss. The first case we are discussing right now, right, the uniform circular motion and the simple harmonic motion. Second, mass spring system or Hooke's law. Third, we're going to discuss about simple pendulum. In all of the three cases, the maximum displacement would be at extreme position, and the minimum displacement would be at mean position, right? This I've already cleared. Why is it so? Since at since displacement is always taken away from the mean position, which means at mean position it would be 0. We must take displacement away from the mean position, and till what this displacement can go, till its extreme point, till the limit it has. So at extreme position the displacement would be maximum, at mean position the displacement would be minimum. So in today's video we have discussed, or we have completed the derivation of the displacement, or derivation of finding the displacement, derivation of the formula for finding the displacement of the shadow or the projection of a particle which executes simple harmonic motion, right? In the next video, we're gonna drive the formula for the velocity. I'm gonna make everything very understandable, so that everything must be clear to you. There must be nothing remaining which you guys say that it isn't clear to us. Everything will be crystal clear to you all.